Hello, this is the video for 1-6 Part 1, Converting Things into Scientific Notation. Scientific notation is something you guys have done before in elementary school and in science class, but you might not remember that you've done it before. So let's talk about what is scientific notation. These are extra notes that we took in class that are not on your notes sheet. Here's the thing, when scientists started studying things like really huge things like the distance between planets or the mass of a star or something, tremendously huge, they had all these really large numbers that were difficult to work with when they were writing reports and things. So they came up with scientific notation, which is a shorter way of writing really long numbers. Okay, so we have this number right here, 5, some kind of illion, like million, billion, trillion, quadrillion, quintillion, hexillion. I don't know if that's even a word. Okay, so a huge number. Let's say that was the mass of a planet or something. That's huge, and you wouldn't want to write that like a whole bunch of times in a lab report. Now, if you're thinking, well, who cares? I'm not going to be a scientist. Well, your high school and middle school science classes will still involve scientific notation, particularly if you take chemistry. There'll be a lot of scientific notation in chemistry. Okay? So here's what it looks like. When you do scientific notation, if I were to put this number in scientific notation up above, this number up here, if I put that in scientific notation, what I have done is put a decimal after the first number. Okay, so that's this decimal. Then I write down all the numbers that are not zeros. Basically the idea is, let's cut off the zeros and just write down the other numbers. 5.482. Okay, then we need a times 10. And what times 10 does is it's going to show us how big the number is. And however many times you multiply by 10, multiplying by 10 keeps the number the same but moves the decimal over. Okay, so the exponent tells us how big of a number we're talking here. Okay, is it 5.482 million, 5.482 billion? Okay, the exponent tells us how big it's going to be. So how do you determine how big the exponent is? Well, you have your new exponent that I just put in, and then I'm counting all the values to the end of the number, whether it's a 0 or not a 0. In other words, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 numbers came after the decimal point. Some of them are non-zero numbers and some of them are zeros. I have to count them all. So that's where the 21 came from. Okay, so scientific notation is always a single digit to start with. It's always one number. And then after the decimal is any numbers that came after that but aren't zeros. Unless it was a 0 in between, and then that counts. And then times 10 is always part of it. And there are 21 digits from the new decimal to the end of the number, so that's the 21. Then you had, the scientists that are studying extremely small things, like how much does 1 grain of sand weigh at the beach? And those are extremely small decimals, all right, 0.000 to the end. Okay, so scientific notation still should start with a single digit number. So now I'm putting the new decimal after the 1. Okay, 1.25 is what I'm bringing down. 1.25 times 10. We always are doing times 10. This time our exponent is negative because it's negative exponents that make decimals. And what we're counting to get the number is one decimal to the other decimal. Okay, we don't count the 25 on the outside over here, and we don't count the 0 over here. We just count what's inside this box, this part of a box that I drew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 digits. Okay, the 1 right here still counts as a digit. We're counting all digits between the decimals, not just zeros. Okay, and that is how you would write that in scientific notation. So now going into our notes. To convert a number into scientific notation, starting at the left, place a decimal in front of the first non-zero number. So if I was doing each one of our examples at the bottom, just doing that step, I would put a decimal after the 7. I would put a decimal after the 8. Starting at the left, I would put a decimal after this 8. And starting at the left, I would put a decimal after this 7. Okay? So that's that part. The next part, I am going to write that number down along with the not 0 digits after our new decimal. Here's what I mean by that. So 7.5 would go on the line. 8.56. 8.23. 7.2. Then for each answer, I'm going to write the times 10 because scientific notation is always times 10. Why? Because we have a base 10 number system. There's 10 digits in our number system. But you just have to remember it's always times 10. Okay, now to find the exponent, count how many places did that decimal move from its original spot. Okay, so in bigger numbers, okay, thousands, millions, billions, trillions, you're taking that new decimal you drew and to the end, how many digits are in that box? 3. Again, start at this exponent, go to the end of the number, how many digits? 1, 2, 3, 4, 5, 6. For really, really small numbers, these decimals that start out 0.000, okay, you're going to count how many digits are between your exponent, or between your decimals, excuse me. Old decimal, new decimal, there's 1, 2, 3, 4 digits, and it's -4 because it's a decimal. Old exponent, new exponent, there's 2 digits in there. Because it's a decimal, I'm going to put -2. Okay, so coming back to filling in our notes, the exponent is positive if the number is greater, and the exponent is negative if the number is less. Okay? Okay, this is as far as we're going today in class. If you had me first period, this is a change. I actually did the whole lesson in first period, but based on your exit ticket data, I made a change for the rest of the day. Tomorrow we're going to be doing the second part of this lesson, which is taking stuff in scientific notation and moving it back into standard form. So for all classes 1 through 14 on the homework will be due tomorrow, and the rest of the worksheet will be due on Wednesday. I just decided to change up the lesson timing a little bit to accommodate I think we needed a little more time on this. Have a great day, and I'll see you tomorrow.